Good morning, grade 10. In previous video, we have seen in detail basic proportionality theorem. Today we are going to see what is converse and then we are going to solve set 1.2. Now theorem says that if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same ratio. If BC line parallel, so BC is parallel to DE, if this is the condition in a triangle, then AB upon BD will be equal to AC upon CE. This is your theorem. Now see the converse. You can concentrate on this if and then word. Look at this if and then. Okay, the sentence which is following if and sentence which is following then, if you interchange it, you are going to get the converse. That is what we have seen in 9th standard, how to write the statement and the converses. So we are just exchanging and then what we get? If a line, now it is not saying that a parallel line, okay. If a line divides any two sides of a triangle in the same ratio, that means now here the ratio is the same, then the line is parallel to the third side. Then this line will be parallel to the third side. So in theorem, line is parallel to the third side is given and therefore the ratios are equal. But in converse, if the ratios are coming equal, then we can say that the line is parallel. So understand this because you will have to write the reason. Sometimes theorem you are going to use, sometimes converse you are going to use. So whenever you are going to prove that the line is parallel, in case of triangle and like this situation, you should be writing using converse. And when you are finding the ratio, provided the line parallel is given, you are going to write it is by basic proportionality theorem. So let's go to the problems now. Now this is your second question. Mind well students, only 2nd, 4th and 10th question will be there this year. Others have been reduced from your syllabus. Okay, now see here, complete PQ is given as 25 and PM is given as 15. You know that P, M and Q, all these 3 points are collinear. And therefore PM plus MQ will give you PQ. That is what I have written over here. Substituting the values, you get MQ is equal to 10. We have PM 15, PQ is 25. So 25 minus 15 will give you MQ which is 10. Similarly, P and R, these 3 points are collinear. And therefore PN plus NR will give you PR. That is what I have written here. Substituting the values, PN plus 8 is 20. And therefore PN is 20 minus 8 which comes out to be 12. Now see, we are going to state if NM is parallel to RQ. This is a triangle. When this side will be parallel to this side? Only if these two ratios will be equal. If Pn upon Nr is equal to Pm upon Mq, if ratios are coming equal, then by converse of basic proportionality theorem, we can say Nm is parallel to Rq. So your first job is to find out the ratio. So let us find the ratio. Pn upon Nr. How much is Pn? We have found out 12. So 12 upon, how much is Nr? 8. Okay, 4 3s are and 4 2s are. So ratio is 3 upon 2. Now how much is PM? PM is 15. And how much is MQ? MQ is 10. So 5 3s are and 5 2s are. Again this ratio is coming as 3 upon 2. Aren't these two ratios same? So what we got? Pn upon Nr is equal to Pm upon Mq. Pn upon Nr is Pm upon Mq. This we got from which? We have got from 3 and 4. So we can write here from 3 and 4th step. And therefore, NM is now parallel to RQ by converse of basic proportionality theorem. I think it's clear. Okay, let's go for the next problem. Now this is your 4th question. Diagram is like this. It is shown in the textbook and it has been asked to prove that AP upon PB is equal to AQ upon QC. So we are going to prove that the ratios are equal. When can we prove that the ratios are equal? Only if we know that PQ is parallel to BC. Alright. So here neither the line is parallel is given and ratios we have to prove that they are equal. So something hint they have given, that is 60 and 60. Now with this information given, we can prove PQ is parallel to BC. Very carefully observe. Measure of angle APQ is equal to measure of angle ABC, that is 60, which is given. Now if measures of angles are same, the angles are congruent as per the definition of congruent angles. So I have written the angles are congruent here. Here I have written measures are equal. Now because these two angles are congruent, then we can say PQ is parallel to BC. Consider two lines PQ and BC and AB as transversal. So if AB is transversal, then this angle and this angle are corresponding angles. So if corresponding angles are equal, the lines are automatically parallel. Alright, and therefore we write here corresponding angle test for parallel lines. We can say PQ is parallel to BC. Now once the lines are parallel and this is a triangle, PQ is a line which is parallel to one of the side of the triangle. We can say in triangle ABC now, PQ is parallel to side BC. From here we can say, and therefore now AP upon PB is equal to AQ upon QC. As the line is parallel, ratios are equal. So what we are using? Basic proportionality theorem we are using, not converse. In theorem, we are going to prove the ratios are equal. Line is parallel is now given. Why it is given? We have found out with this information. Alright? Okay, let's go to the 10th problem now. You may pause the video and take down the steps. Now this is your 10th problem. It's very easy. You can see that this big triangle, inside one point is given X. You can see these three different triangles, XDE, XEF and XDF. So 1, 2 and these three triangles you have. Now say in triangle XDE, this triangle you are going to see, this side. You know that PQ is parallel to DE, it is given. If these two lines are parallel, turn this triangle and imagine you have XQ upon QE. XQ upon QE, here should be upon sign, will be equal to, see, XQ upon QE will be equal to XP upon PD. Okay. Similarly in triangle XEF, now QR is parallel to EF. So you have XQ upon QE is equal to XR upon RF. XR upon RF. Now look at these two ratios very carefully, 1 and 2. XQ upon QE is here, XQ upon QE is here also. You know that if A is equal to B and B is again equal to C, A will be equal to C. So with using this property from 1 and 2 we get XP upon PD is also equal to XR upon RF. Okay. Now look at the ratios XP upon PD. See, XP upon PD. That means this side of triangle is divided into the ratio. Is equal to XR upon RF. XR upon RF. Now the ratios are equal. Therefore we can say PR is parallel to DF. I guess in the textbook here by mistake E is written. It is DF. This is the side DF. And therefore now because the ratios are equal, we are proving lines are parallel. And therefore we are going to use converse. Converse of basic proportionality theorem. So I think it's very easy, students. And that's all for today from my side. Rest all the problems are reduced from your syllabus. So this is the end of your set 1.2. Thank you.